So multiple choice, the difference between a voltaic cell and electrolytic cell is that. Can you try?
بس هو الفولتاك سيل هي الالكتروكيميكال.
Yes, voltaic or electrochemical, or it's called galvanic cell also.
سي.
So the cathode is labeled as negative in an electrolytic cell and as positive in a voltaic cell. This is correct. ممتاز. So I will say that this is correct. The oxidation will occur only at the cathode in the voltaic cell. غلط. It happens in the anode for sure. And the free energy change is negative for an electrolytic cell. Of course, it's not because it is non-spontaneous. And the electron flow from the cathode to the anode in both types of cells through the external wire. الكلام ده مش مظبوط. There is no electron flow in the last one. في the last one مش هيبقى فيه electron flow. مش كده؟ هيبقى فيه ions flow mainly. So there will not be an electron flow. هيبقى ions flow mainly. ممتاز. So let's take the second one. And let's copy this. And this. Okay, the second one, consider a voltaic cell. I'm not sure this is not. Now consider a voltaic cell E naught cell is equal to 0.62 composed of cobalt, copper, and their respective M2 plus ions. And then what is the E naught for the anode half cell? Is the choices not showing? Yeah, here are the choices.
سي.
So how did you get C?
0.62 minus 0.34.
So 0.62 minus 0.34. So we'll get C, and the answer is not C.
Is it B?
Well, how come? How did we get it? Okay. So we have to explain now.
Because the half قصدي ال node, it's for the reduction, so we flip it so it becomes positive and we add them.
Exactly. So we add them and then it will be 0.28. That's perfect. Very good. Next one is this one. What takes time? So much time. Okay, here it shows what does the line notation below indicates. pH, P2H2H plus, copper 2 plus aqueous, copper solid. Copper is the anode, platinum is the cathode, copper is the product of the cell reaction, hydrogen gas is the product of the cell reaction. I don't. Sorry.
See?
So Cu is a product of the cell reaction because Cu2 plus changes into Cu, and that's correct. Very good, excellent, ممتاز, because when I'm making the products in the cell notation, it's usually showing here. So H2 changes into H plus, and copper 2 plus is reduced into copper. So this is the product. ممتاز. Copper is the anode. You cannot say the copper is the anode because copper is formed, right? So copper is formed, it is copper in copper 2 solution. So we cannot say that because copper here is copper here, and this is copper 2 plus, and this is oxidized or reduced. This is reduced. Since it's reduced, so it is the cathode, not the anode. And platinum is the cathode. So no, it's the opposite. Again, it is the anode. So he thinks platinum and hydrogen inside. This is the anode. And hydrogen gas is a product of the cell reaction. No, hydrogen gas is a reactant. So perfect. That's very good. So number 4. Balanced formula have a reaction in an acid solution. When balanced with the smallest whole ratio, the sum of all the coefficients is. Well, how come this will be like that? Let's see. Okay. Shall we do it together? Shall we do it together? Yes, better to do it together. This is NO3 minus is changed into NH4 plus. So what do I need to balance it? I need oxygen, right? How do you add oxygen? By adding water, correct? So I need to add water. How many water molecules I will add? You still can see the solution? Hello. How many water molecules I need to add?
2.
I need 3 because I have 3 oxygen atoms and I need 3 oxygen atoms, so I need to put 3. And now hydrogen is 6 here and here 4. So here I need how many hydrogens? 5 here, H2. And then what about the charge? This is 1 electron and this is, so I need to add an electron here, right? So this is, if I added 1 electron, it will be 0. So I need to put 2 electrons, so it will be -1. Now let's try to find the coefficient total. So 5, 6, 7, 8, 9, 10, 11, 12. 5, 6, 7, 8, 9, 10, 11, 12. So it's coming as 12. Let me try to do it one more time. It is H plus, let me do, I think. Oh, we need to add protons. We don't need to add protons. I'm very sorry. We need to add protons. We need to add 10 protons. So 10 H plus, right? We balance with the H plus. We balance oxygen by the water and the hydrogen by H plus. So we need to add 10 protons. So we balance the 4 and the 6, 10 hydrogens here. Here 10 hydrogens, so 10 protons. Now what is the charge? The charge is plus 9 here and here plus 1. So I need to add electrons. How many electrons I need to add on the left side? 8 electrons, correct? If I added 8 electrons, it will be positive 1, so it will be balanced. Now what is the total? 8 and 10 and 1 and 1 and 3. So 18, 19, 20, 23. That's the total as 23 moles. Okay, so again, we balance oxygen by H2O. We balance hydrogen by H plus. Then we balance the charge by electrons. Very good. So next one is the following reaction is thermodynamically favored. So the activity series for the three elements from the easiest to oxidize to the most difficult to oxidize is what? Can you try it?
مش فاهم.
Okay, now I have thermodynamically favored, means this is happening or not happening. These three, are they happening or not? They are happening. So which one can displace which one? Copper and silver, which one can displace? The copper is displacing silver or silver is displacing copper? The atom is
Silver
displacing the
displacement.
ion. No, we know that it is AI, right? The atom is displacing the ions. So this means that which one is more active, the copper or the silver?
Copper.
The copper. So the copper is more active than silver. And zinc is replacing silver. So this means that zinc is more active than silver. And zinc is replacing copper. So this means that the zinc is more reactive than copper. So this means that zinc is more active than copper than silver. So it is B, right? It is answer number B. Okay. Next one. So the standard reaction potential for lead oxide is 1.46 and the standard reaction potential for Fe3 plus is 0.77. What is the standard cell voltage for the following reaction?
It's A.
No, let me know how did you answer this one. The lead oxide is changed into
ثانية عرفت اتلخبطت ثانية. Okay. It's B.
So it is B. So plus 41.46 minus 0.77. So it is 9 and then 9, 7, 16. And then this is 14 minus 7 is 13 minus 7 is 6. So it is 0.69 positive. Okay, next one. So question 7 and 8 refer to the following half cell reaction. What would the standard electrode potential for a voltaic cell properly constructed from these two half cells? If I put these two half cells together, am I going to get 1.02, 0.64, 0.46, or 1.02, but negative this time? So I have A, B, C, and D, and what is the correct option?
C.
So the answer for number 7 is C. Very good. So that's C. So I just make the CR3 plus is more negative, so that would be reversed into 0.74. And this is stays 0.28, so it is 16. And this is 46. Very good. Okay, and that was easy, I think. Okay, if I ask it number 8, because it is for the same question, what is the correct balanced overall equation for this voltaic cell?
A.
So the reaction is A. Excellent job. So the cobalt will be as it is. The cobalt here is as it is. That one will be reversed, so the chromium will come to this side, and this one will be on the product side. And this has 3 electrons and these 2 electrons, so must multiply everything here by 2 and here by 3. So this becomes the 3 chromiums, 2 chromiums, and this is 2 Cr, and this one becomes 3 and 3. So that's correct. ممتاز. Excellent. طيب. Okay. Within the following pairs of compounds, which pair contains the element named with the same oxidation number? We gotta get it some time. We gotta give it some time to find out the oxidation numbers.
A.
Okay, we got lucky and we got the answer from the first one. This is saved out a lot of time. So H2S2O7 means that this
بس
is
اللاكي
all
ازاي؟
lucky because you got it from the first one, right? You didn't. Did
لا
you do all
والله
of
انا عملت.
them? You did them all? Okay, okay,
اه
that's
انا
good.
عملت اول واحده، صح صح.
That's okay.
This gets
That's
lucky.
it. That's good because it saved us time. In the exam, actually, if we have time in the revision, it will be better to do the rest of them. Okay. So give me a second. I will reply to this phone. Okay. Okay, sorry. Let's get back to the session. So the next question was number 10. I should have given the question. Sodium metal cannot be electrolyzed from an aqueous sodium sulfate solution because What do you think is the answer? We know that one.
B.
So the answer is, want to think it again?
B.
B.
لا
Why is B? Why is B? Why is B?
بصراحة مش متأكد.
لا احنا عارفين الحكايه دي من زمان. ليش ما بنعملش الومنيوم اوكسايد؟ نفس الشيء الومنيوم اوكسايد. ليش بعمله مولتن وما بعمله اكويس؟
عارفها.
صح؟ Why is that? Because
كنت عارفها
okay. So it is
عشان ميتال أوكسيد.
لا. When you try to electrolyze sodium sulfate, what are the products of the electrolysis? What are the four ions available and what are the products of the electrolysis?
أيوة صح.
Hmm.
We take the less reactive one.
We take the less reactive one. So sodium will not be released. What will be released?
Hydrogen.
Hydrogen will be released. It will form hydrogen ions, right? Hydrogen H2. So H has more favorable reduction potential than Na plus. That's why it is the one that's gonna be reduced, not the sodium. It has more favorable reduction potential than sodium plus. Okay, let's see the next one. Which of these elements has the largest number of possible oxidation?
Fe.
So Fe, largest number of possible oxidation, it has Fe2, 3.
Fe.
Chlorine has 1 only. Calcium has 1 only. What about manganese?
It has 2 and 3.
It has 2 and 3. Okay, iron has also 2 and 3.
أنا عارف
So,
الأيرون عندها 2 بس، فأعتقد المنجنيز عندها أكتر.
okay, and the surprise is chlorine. Do you remember always we are saying chlorine never do? We are always saying never do chlorine at the beginning of oxidation and reduction oxidation states. Chlorine, nitrogen, and phosphorus, and these guys are very tricky. The chlorine has -1, +1, +3, +5, and +7. So the chlorine has 5 oxidation states. That's why we usually never start with the chlorine. Usually the chlorine, nitrogen, and phosphorus are from the things that we keep, and also sulfur at the end. Why? Because they can have a lot of oxidation states. Okay, that's good to know. And next question is for the reaction, this one. My standard cell voltage is 0.82. What is the equilibrium constant for this reaction? So we need to find the Q for the K for this reaction. We have the R, we have the F. You still remember the equation?
حاجة ln أو log K.
Okay.
بس حاجة minus أو plus RT log.
طيب delta G is equal to negative RT ln of the K. So delta G is equal to negative RT ln of K. What is R? 8.314, right? And what is T?
45 plus 273.
45 plus 273, which is 8 and 1 and 318. And what is the ln of K? We need to find the ln of K, and we have the delta G. No, we
No.
don't, no, that's only, we don't have the delta G, we have the standard cell voltage only. We have only the standard cell voltage, so we can use a different equation. We can use a different equation. What is the different equation we have? We can say delta G is equal to minus N Fe cell. So we can say that delta G is equal to minus N Fe. So delta G is equal to how many electrons lost and gained?
2.
How many electrons? 2 electrons. So -2 multiplied by F, which is 96485, multiplied by the E,
لا
which
مستر
is,
مش هي 1.
let me see, you said 2 and then I followed you. So I minus has changed into I2. It has gained lost 1 electron, but there are 2 here. I minus had,
2.
I change it into I2. So 2 electrons, yes, 2 electrons and 2 electrons. So 0.82, let's get the value of delta G.
So we don't have it, so we equate the two equations.
Let's find the delta G. Yes, we will say this is delta G and this is delta G. So we can just equate them and find the, because we will be having N and F and E, and we just need to get this answer. So once we find it, we will put it here. Let me type it down on the calculator here.
So I got the answer.
What was the answer you got?
A.
It is A. So the answer, yes, correct, that's A. So we'll get the K is equal to 59.8, 9.8 multiplied 10 to the power of 25. And for anybody seeing the video, we'll just make this one equal to this one, and then we'll find the len K, and then from the len K, we can put this to the power, so we can get the K itself, which is 9.8 multiplied 10 to the power of 25. That's excellent job. Okay, and then number 13. Now we need to find the delta G for this cell if the reaction is 1.59.
So the answer A.
The answer is A. Let me check here the answers and let's do it. So we are saying that this cell calculates the delta G for the reaction. So we'll use the same equation. Are we going to use the same equation for 13?
Negative
Minus
NFE.
Fe of the cell. Then you will get 921 kilojoules, which is A. So negative N the same way. Okay, and then let's go for the next one to answer as much as we can. Number 14, a matter is electrolyzed from aqueous solution by using an electric current of 1.23 ampere for 2.5 hours, and 3.37 grams of metal is deposited in a separate experiment. The number of electrons used for the reduction of the metal is 2. What is the metal? So you need to find the
Mass.
molar mass. We need to find the molar mass. We have the mass already, right? We have the mass already. We need to find the molar mass. And once we find the molar mass, we can know what is this element. So we will say that actually the mass is equal to what? I multiplied by time divided by F multiplied by
molar mass.
Molar mass over
Number of
electrons. So we can say that this mass, which is 1, we have given everything 3.37 grams, and this is 1.23. The hour, I have to change it into
seconds times
so
3,
times 60
3600.
times 60, and then divided by F, which is 96500 or 96485 if given. And then the MR is required to find, and the N is 2 electrons. So what will be the MR?
58.7.
58.7, which is the molar mass for the periodic table.
مش قدامي periodic tables.
I'll bring it. I'll bring it. I will bring this desktop, exit, and not the logo, not the periodic table. Yes. Screenshots to see the periodic table. This is for the periodic table. Yes. So let me share here this one as well. Oh, this one. Share. Okay. So what did we say? 58.7, which is
Nickel.
nickel. Okay. Very good. We go back to the screen. So it is nickel number B. Excellent work done. Okay. Right. Next one is oh. So I have constructed a galvanic cell here by using two half fractions listed below. A galvanic cell is constructed. Okay, what do you need to know? I need to know once the cell is operational, which of the following is contained in the anode compartment of the cell?
مش شايف السؤال.
Oh, which? So open board, let me share. Using the two half fractions, a galvanic cell is constructed. Once the cell is operational, which of the following species is contained in the anode compartment of the cell?
حاجة في الكوبالت صح؟
حاجة في الايه؟
زي الكوبالت.
What is the answer? A, B, C, D. So I can tell you. It's D.
دي
Is D. Yes, it is D. Correct. So once the
بس
cell is
فين الكوبالت 2 بلس.
so let me tell you again. Once the cell is operational, which of the following species is contained in the anode compartment of the cell? So this is the anode. Right. This is the one that's going to be oxidized, correct? It's more negative. So this is oxidizing. So I have a cobalt here and cobalt 2 plus here. And then this is, I have copper here. This is the cathode. And this is the copper and copper 2 plus. What's your question again?
في دي مش مورية الأيون بتاعت CO2
So I think they have missed the question. I think they have missed the question, although it is a respectable book. But they have messed up with the question. Let me see the answer. At least maybe have fixed their mistake in the answer. Oh, they are talking about iron. I don't know what is it. They are saying, oh, I think this is like a book error because they are saying in order to function properly, the overaction should contain, and this is a question that they have shown in the answer. Can you see? That's nothing related to the question, and still there is no ions also. Still there is no ions. So this is a mistake in the book. Let's correct it for them. So I'll just say 2 plus here. We know better. Okay, good for you. Type. Let's see next one.
في حد على الباب، ممكن افتح بس بسرعة.
Yes, sir, for sure. Okay, so let's see this one.
So I'm not sure.
Okay, if the E note for the reaction, you have to pick something, right? Don't forget you have to pick something. Pick anything. Maybe you are lucky. Just pick anything. You must pick anything, even by luck in the exam.
A.
No, it's not A. Okay, so let's see. So now you are saying if the E node for the reaction X plus E electron is X is greater than the E node for A2 plus 2 electrons plus A, which statement will be correct? If you said that this is greater, so this means that this is oxidation will happen for it. Which one will oxidize? This is more positive, and this is more negative.
ايوه، يبقى
Right?
ايه هي الاكسيديشن، صح؟
I don't see what is this one. I think he has to put an arrow here, right? Also, right? Too many mistakes. Yes. So air is oxidation, correct? So
ايوه.
I can say that A reacts with X plus to form A2 and A. Oxidize it to A2 plus change it into A. So this means that this one will be reversed. So I will write it like that. Let's write the equation after reversing. So A will change into A2 plus 2 electrons. And this one will remain as it is X plus, and this is X. So which one displaced which one? Which one displaced? This one is displaced this one. So which one is oxidized? The A lost electrons and become oxidized, right?
Oh,
And what did it do to the X?
reduce.
It reduced X. So A will reduce X. X will oxidize A2 plus. No, it does not oxidize A2 plus. It oxidizes what? It oxidizes A. It oxidizes A. So if it is A here, it would have been right, not A plus. And you cannot say X will oxidize A2 plus because X is not in the reactants, X is in the products. And you cannot say X will reduce A2 plus because also X is not in the reactants, X in the products. So the only correct one is C. Got this one? If you just write the equation, then it will be very easy to understand. Okay. Like which of the following compounds include an element that has the same oxidation number as the chlorine in sodium chlorate, NaBrO3? Has the same oxidation number as the chlorine in the sodium chlorate, and he has put bromide. What happened to the book? They have lost their minds. So it's saying chlorate, and they put bromine. So let's say NaClO3. Let's cover for them. There is no revision.
So do I count K as +1?
K as +1. Yes, that's an easy one. +1, and the other one is -2. Memorize it.
So is it C?
So the answer for number 17 is C. Thank you so much. And number 18, with a current of 1.25, what is the time now? The same question like the before, but now we are having time. You are almost done with the MCQs, and then you take the other one.
So what's the molar mass of copper?
The molar mass of Mr. Copper is shown here as 63.546.
Mr. Can you go back to the question?
Yes, sir.
So it's B.
Oh. The correct answer for 18 is B. Thank you so much. That was very good. Okay, number 19, almost done. 3 more questions. What is the minimum number of electrons needed to balance the following half fraction with whole number coefficients?
Mr. We add water on the right.
We add water on the right. How many water molecules?
And hydrogen on the left.
And I have 6 hydrogens. And then electrons on the
left and right.
Why left and right? What is the charge on the left and what's the charge on the right? On the left,
5
it is,
electrons.
yes, 5 electrons on the right side only. On the left side only. This is plus 5.
It's not 5, it's 7, sir.
Why it is 7? It is plus 5, plus 6, and minus 1. So this is plus 6 protons, and this is negative 1. Negative plus 6 and negative 1. So total is plus 5. So I need 5 electrons here. So I need 5 electrons. So the answer is C. Okay.
Mr. On the right side, do we put electrons or no?
Wait. They are saying the answer is D. So let me have a look. What did I do wrong here? How many oxygens we put? We put 3 oxygens, right? 3 water molecules. We put 3 water molecules. We did a very big mistake. What is the mistake? We didn't balance the iodine. We didn't balance the iodine, so we failed. Oh my God, we failed. So you have to balance the iodine first. So iodine is 2iO3 minus give us I2, and then we will work it. So how many water? 6H2O, then 12H plus. Now this is 12 plus negative 2, so it is 10. 10 plus, that's why it is 10 electrons. Unfortunately, we didn't do correct, but hopefully that's the last time we do this mistake. Okay, always focusing on oxygen and hydrogen and forgetting the main atom that has to be balanced. 20 and 21 are the last 2 questions, so let's put them together here. So let's take this here in one page. Shown below are 12 reaction for nicotinamide, adenine, dinucleotide, and oxyl acetate and their electrodes. Determine the E cell for the following reaction and predict if the reaction is thermodynamically favored.
B.
B. What is the answer? How did you answer?
لا مستر سامي ما شفتش الايكويشن تحت بس خليني اتاكد من الاجابه.
Oh, okay.
لا لسه بي.
Okay, so let's see which one will be oxidized and which one will be reduced. Mr. He says that these two have reactions. So he's saying that this is the one reduced and NAD plus took electrons, and this one is reduced also. So I'm gonna reverse this, right? Mr. We have to follow the equation. So am I going to do the right thing? Well, I'm going to see what is the equation contains.
Equation.
So the equation is telling me that the oxaloacetate has been changed into malate. So this means that it stayed as a reduction or it is reversed?
Reversed.
Why? Still here is oxalate reactants and here products, no change.
بتكلم على الايكويشن الثانيه مش دي.
The second equation NAD plus has been moved here, so he has put the plus 0.320 and minus 1 minus 0.166. So when we add these two together, what do we get?
$154.
We get 154. That's the result that you got. That's why you are insisting here. So this one is reversed. We make it positive, and this one is okay. Again, let me have a look again. So again, the reduction is so.
في حاجة غلط.
Yes, there is something wrong.
أعتقد غلطة في الكتاب.
Let me just have a look here. So the action is not negative since okay, I think they are making a mistake again here. So let's just do it ourselves with the way we know. We are very sure, yeah, we are very sure that this one is being oxidized and reversed because he is saying that NAD here is here and NAD is here. So it's very clear, and NADH is here, so he has reversed this one. So it becomes 3.20, and this is negative 0.16. So it became 0.154, and this is thermodynamically favored. The book is saying the answer is D, which is incorrect, because if he wants the reaction to be D, then this means that the opposite is reversed, right? Now 0.320 and plus 0.166. If we get it like that, it will become negative 0.154, and this is negative, so not thermodynamically favored. But this means that he has reversed the first. This means that he has reversed the second one, and the second one is not reversed. For the following, it's not reversed. The first one is reversed. This is totally for sure wrong, 100% wrong. Let me have a look at the book again and see what is his explanation. Bismillah. He's saying that NADH is being oxidized in this reaction, and the auxiliary acidity is being reduced. So he's saying again that NADH is being oxidized in this reaction. NADH has been oxidized, it changed into NAD plus. And when this happens, it has lost electrons. So yes, that's oxidized. So if it is oxidized, you should reverse its sign.
مستر
نعم.
وأنا لسه حاطط السؤال على شات جي بي تي وبيقول لي الانسر بي.
Yeah, it's very clear because he even in his explanation, what did he say? He said the NADH is being oxidized. So if it is oxidized, why you did not reverse it? If it is oxidized, it should reverse it, right? So you should have reversed it. He put negative 0.32 and he did not reverse it. He said minus negative 0. So he said the reduction minus oxidation. And the first one is negative minus oxidation. But he put the other one as negative. So minus negative. So minus, no, we are correct. احنا اللي صح. Okay, next one. So the answer is B. Okay, which of the following statements is false? Reduction involves again of electrons. Batteries are galvanic cells. A thermodynamically favored reaction always has a positive E node cell. So reduction involves again of electrons. That is correct. Batteries are galvanic cells. That's correct. Thermodynamic favored reaction always has a positive E node, so that's correct. Electrolysis reaction always produce a gas at least at one electrode. Who said? So if it is electrolysis of, for example, produces a gas at least at one electrode, this worth thinking. But if it is iodine, or if it is, for example, sodium iodide, right? Aqueous sodium iodide. What is the product? It's hydrogen gas. Let's not say, let's say copper iodide. If I say copper iodide, what are the products of copper iodide aqueous?
Cu2 plus I2 plus
It is
2I minus.
copper solid and iodine is dissolved in water, it's aqueous, right? So it's not necessarily a gas. Here, not a gas produced. طيب, the free response questions are these ones. A galvanic cell constructed by using, a galvanic cell constructed, again. Using substance in following cell, what is the E node cell for the reaction? So Ni2 plus has been reduced to keep it as it is. The iron has been oxidized reversed, so it will be plus 0.447 and minus 0.257. That when we do that, what do we get? Bismillah. We get this one plus this one, which is 0.919, right? Did you get the answer? Or you already done, finished? Node reduction minus node oxidation.
Which flip the more negative one.
Yes.
لا, look at the equation, صح?
Correct. So let me just say, what did he do wrong? Minus negative plus. You know what? I got what he did wrong last time. He just did a math mistake. So he said negative 0. This book should be well revised before giving this. Negative 0.6 plus 0.166. No, it's not a math mistake. What did he do wrong? He did not flip the right one. So reduction here, he said negative. It's very weird. Zero two three. Yes, I really don't know how he makes this mistake. Three two zero. So 320. It was negative, and he make it negative as it is. Then he did negative the negative. And here the same, he's doing negative and negative for the negative. There's the reaction minus oxidation. Just think about it. How did he do this wrong? He cell in cell. Wait. It was 0.32. Okay, I'll try to see how this makes such a mistake. What is the E node cell for this reaction? We got it. Which reaction takes place at the anode and the cathode? Of course, this one is reversed, so the anode is the oxidation for sure, right? Correct? We're still here. And the cathode is the nickel, which is the reduction. Sketch a galvanic cell in which this reaction takes place. Very important to know how to draw the galvanic cell. So we need to draw the containers, and what is inside the containers here? Can you tell me what's inside the containers? Where did you go? Still here?
I was muted the whole time, ما كنتش قصدي.
Okay. So what is inside the container? One of them contains what? Nickel and nickel. So which metal I have? I have
Nickel,
the nickel inside nickel solution, and then
iron, and
iron inside iron solution. Don't forget the salt bridge, the voltmeter, and everything should be cool. And shows the direction of electron flow. How do the electrons flow?
from anode to cathode. Nickel to
So it goes from the
no, from iron to nickel.
so iron to nickel. So the electrons move from here and goes here like that.
Oh,
And then what about the movement of ions in the salt bridge? You said that the cations go to the
cathode.
and the anions go to the
anode. بس ما فيش anions هنا.
in the salt bridge. The salt bridge contains the anions and the cations. So when he's talking about cations and anions, he's talking about the ones in the salt bridge, the potassium nitrate. Remember we answered this question?
Oh,
So the potassium goes for the cathode and the nitrate goes for the anode. Okay, calculate the K equation for this reaction. Is this reaction thermodynamically favored or not? So again, we'll say that delta G is equal to minus NFE again. And again, the delta G is equal to minus RT ln K. And then I can equal them again to find the K the same way that I found it. Can you try to find it? This will be our last question for today. Try to find the K.
So what's R? It's 8.314.
R is 8.314, yes.
What's delta T? O T.
T is the temperature not showing here. Yeah, it's not showing, and he will not write it.
فخليها 298.
Yes, sir.
Okay, the answer is 1.85 times 10 power of 64.
10 to the power of 64. Is this the K or the ln of K or what?
That's K.
Okay, how many electrons are there?
2.
Okay, and what is the voltage?
Voltage?
Yes.
1.9.
1.9. So why the answer is not correct? 1.9 or?
حطيت 1.9.
We'll see. These guys, 0.19 or 1.9?
What? أنا حطيت 1.9.
Okay. Very small mistakes.
The answer is 2.67 times 10 power of 6.
It's 2.62 times 10 to the power of 6, right? That's the correct answer. Excellent job. Very mild mistakes and very few mistakes. That was our last question for today. I see it's not bad at all, but let's take care about the small numbers. I'm gonna go and dig deeper after this book for these questions that you make mistakes عشان أشوف إيه المشكلة. And thank you so much. See you next time إن شاء الله.
شكرا.
أنت الامتحان الجاي بتقول إمتى بتاعك؟ Your next exam?